And when you put on the UVW power, it locks clockwise. And now with them both pointing in the opposite direction, it goes anti-clockwise. This is at 2 Hertz, 3 Hertz, it's at 4 Hertz, that's at 2 Hertz, 3 Hertz, and so on. What I've done is taken these 6 vertical wire coils, wired up with 3-phase power from this little device, starting at 0, and the south poles are pointing out here, the north poles are pointing out here, and it'll spin. And the reason I've done that is when we spin it, hopefully the magnets won't fly off like they did before. So if we spin it at really low speeds, 3 Hertz, 5 Hertz, you can see it spins very nicely. 5 Hertz. Now what I'm trying to do is spin up at higher speeds and see what happens. Okay, now here's the spin up at 10 Hertz. Here's the spin up at 20 Hertz. Here's a spin up at 30 Hertz. At 40 Hertz. If I do it too fast, the magnets will fly off. And here's the spin up at full mains power. Watch this. Quite a powerful motor, isn't it? 50 Hertz. No trouble with that. Thank you very much. Now we have something more clever made by my friend here. We have 8 magnets alternating NSNS out, and we put on a little bit of 3-phase power. Spins quite beautifully, doesn't it? So 8 magnets are quite acceptable for 6 coils if your magnets aren't too big. Now in order to test this beautiful little motor spinning clockwise at higher speeds, we're going to put on some tape, and we're going to put on a cover so it don't kill anybody. And let's do that next. So now for safety, we've put a couple bands of yellow tape around the outside. We didn't put any over the top. We've put a safety device here with some tape so it won't fly off. And now we're going to try to make it move a little faster. These 8 magnets alternating NNS on a rotor. We're at 20 Hertz. $25, $30, full power. I just want to show you how powerful this is. This is at 240 volts, 1 Hertz. Watch this. Look how much kicking it is at 1 Hertz. It's just tremendous torque being generated in this motor, a 6-4 arrangement. If we just go up to 2 Hertz, which is twice as fast, 3-phase power synchronous motor, U sticking torque between V and W. I'm about to break my finger off. I think it's about to kick me. Let's explain this now. It's very easy. We have 3 wire coils U, V, W wired up in a star configuration. U, V, W. Can't get any easier than that. And above that we're putting a single end magnet. It can be a cube magnet or a disc magnet, and the poles of these are pointing up, so it's going to fire UVW with magnetic poles pointing up. Now if we put a disc or cube magnet over it with an end pole up, for example, it'll stick here. If we put another one over on this side, end pole, it will torque. We put 3 magnets directly over them and turn on some 3-phase power. However, they don't do anything, they just rattle up and down. On the other hand, we have these same 3 coils U, V, and W, and we have 2 magnets rather than 3. Now we get beautiful clockwise torque. They're the same direction. And the way it works is that now when this magnet bounces here, instead of having 2 magnets bouncing here, our third magnet moves sideways. In this case it moves from W to V. I call this VW torque. On the other hand, if I have N on one side and S on the other, now they go anti-clockwise. So N and N go clockwise with this wiring, N and S go anti-clockwise. And you think how primitive we are not to understand this. It's just astonishing. My Tesla Lego experiment this morning, I have a U coil, a V wire coil, a W wire coil, about 1,000 turns of wire. Got a power supply controller 1 hertz anytime. Have 2 magnets arranged the same way, NSNS. They make like a borrowing magnet going across the rotor. And when I turn on 1 hertz of power, the rotating magnetic field in Tesla sense makes the device turn clockwise. When I go to 2 hertz, it turns twice as fast. When I go to 3 hertz, it turns 3 times as fast. Now what I'm going to do is I'm going to hold the rod while I speed the device up. Watch this. On a second simple variation of this experiment, we have 3 coils hooked up as U, V, W in series. Little variable frequency device. We turn both little cube magnets to the north poles point out. So NSSN. And now when we turn on 1 hertz power, they go clockwise rather than anti-clockwise. So it just changes the way they spin. Very cool, isn't it? For this experiment, if I have 4 magnets, all the end poles are facing out. So you have 4-fold symmetry rather than 2-fold symmetry. You turn on the power and it doesn't want to spin, it just waggles. It doesn't want to spin because the 2 different motions are canceling one another. On the other hand, if I have alternating out, in, the 4 poles, and put a little power, then it spins very nicely clockwise, very powerfully as before. This is with 6 magnets at 3 hertz, with all 6 poles pointed out. It just waggles, it doesn't do anything. Clearly not effective. Put 3 magnets on the rotor with all the end poles out like 6. They just rattle also and don't do anything. Need 2 or 4 to make it spin. The easiest solution is just to put 2 magnets like arranged as a bar magnet across the middle. And then it spins up quite easily. I would like to do another very brief teaching video how this three-phase motor works with 6-wire coils and just 2 of the 4 magnets. We just at 2 Hertz 3-phase power. And you can see with 2 magnets it's still going around quite nicely with them. And what happens is when one of those magnets comes to the top of a phase cycle, say phase 1, first it attracts and then it releases a little bit later. Another magnet 90 degrees away was right here. It doesn't do anything, but then as this magnet releases, the V and W coils, one becomes more north-like, one more south-like, and it gives you torque. And we can just see it visually very easily. See, here we have one magnet sitting right on top of a coil, this other in between, and as that magnet over here releases, the other one torques forward. And we just need 2 magnets to see this, and it spins up quite easily. We're going to have a little bit more fun. As you recall, with these 6-wire coils wired up UVW, UVW, our most tightly locked arrangement and smooth turning was NNNN, 4 magnets arranged in a 90-degree orientation. And when you put on the UVW power, it locks clockwise. So very good. Now, what happens if we change 2 of the magnets to S? If we change 1 magnet to S, it made a mess. What happens if we change 2? This is clockwise. Okay, now if we change it to NSNS, change the central 2 magnets. These 2 point out, and now if these 2 point in rather than out, when they're out it went clockwise, and now with them both pointing in the opposite direction it goes anti-clockwise. So we can control very easily 4 magnets spinning inside of 6-wire coils, 3-phase power, UVW, UVW. NNN is clockwise, NSNS is anti-clockwise. We can spin it whichever way you want. Very, very nice and easy. And it spins beautifully, and we made a nice, beautiful synchronous motor, and there's no issues at all. Once again, with all 4 magnets with the end poles pointing out, we don't get any of that jagged roughness. It's a beautiful motor. We've got 6 coils on the outside, 4 magnets on the inside, and making a beautiful self-starting synchronous motor. No need for induction. Look at that. 6 and 4, 3-phase power. It spins like a charm. Next we're going to have 4 magnets, 2 magnets arranged at U and U, and 2 magnets arranged 60 degrees away from U and U, not 90 degrees away. Remember the 90 degrees went clockwise, and now when you turn this on, they synchronize and lock very nicely anti-clockwise. Look at that. Beautifully balanced. So we can make it go clockwise or anti-clockwise depending on the angle between the 2 different sets of magnets. Now if that isn't cool, I don't know what is. So just to be thorough, we know 2 magnets on the rotor will turn a little bit, not very good. 4 magnets will turn great. Let's just see how well 3 magnets all pole out will turn. We put on a little 3-phase power and it doesn't do anything. We can't even get a rotating magnetic field out of it. Okay, let's go on to the next one. Now we have 5 magnets arranged as a pentagon with 6 coils. We can turn the power up and absolutely nothing happens again. Let's see what happens with 6 of them. Now we've got 6 cube magnets with all the poles pointing out. We're going to turn on the power, and it's Rattle City. They don't turn very much, do they? Can we get them turning? Not really. Now here we have 6 magnets that alternate NS, NS, NS all the way around. And again, they won't spin very much, they just rattle when 3-phase power is applied. Here we are with 7 magnets pointing out, and again, they won't spin, just rattle. Now we have something more clever made by my friend here. We have 8 magnets alternating N, S, N, S out, and we put on a little bit of 3-phase power. Spins quite beautifully, doesn't it? So 8 magnets are quite acceptable for 6 coils if your magnets aren't too big. Finally, just as a control, we have 8 cube magnets. They're all north poles pointing out rather than alternating. And we turn on some 3-phase power, and it just rattles but won't turn. So what we require here for the device to turn is either 4 magnets or 8, alternating with 6 coils. The other numbers don't work. One hertz, 2 hertz. And now with the top one to stabilize the rotor, we can spin it up to 10 hertz quite easily.